Multicast routing. Introduction. So communication in the internet today is not only unicasting. Multicasting communication is growing faster. So in this section, first we are going to discuss about the general idea behind in the unicasting, multicasting and broadcasting. So we then talk about some basic issues in multicast routing. So finally we discussed multicast routing protocols in the internet. Unicasting. In unicasting, there is one source and one destination network. The relationship between the source and the destination network is one-to-one. Each router in the path of the datagram that tries to forward the packet to one and only one if its interfaces. Unicasting. So this is the diagram that represents the unicasting. So here we are using the Ethernet switch, point-to-point VLAN and unicast router. Multicasting. In multicasting, there is one source and a group of destinations. The relationship is one to many. In this type of communication, the source address is a unicast address, but the destination address is a group address. A group of one or more destination networks in which there is at least one member of the group that is interested in receiving the multicast datagram. The group address defines the members of the group. Multicasting. So this is the diagram that represents the multicasting. Here also we are using the Ethernet switch, point-to-point WAN, multicast router. So here we are using the different multicasting routers from the source to the destinations. Here we are using the different number of destinations that forms a network. Multicasting versus multiple unicasting. The figure A that shows the multicasting and figure B that shows the multiple unicasting. Multicast basics. Before discussing multicast routing protocols in the internet, we need to discuss some multicasting basics. Multicast addressing, collecting information about multicast groups and multicast optimal trees. Multicast addresses. In multicast communication, the sender is only one but the receiver is many, sometimes thousands or millions spread all over the world. It should be clear that we cannot include the addresses of all recipients in the packet. The destination address of a packet as described in the internet protocol, that should be only one. For this reason only we need a multicast addresses. A multicast address defines a group of recipients, not a single one. In other words, a multicast address is an identifier for a group. So this diagram that shows the needs for multicast addressing. This is a multicast address in binary. Here we are using 1110 group identifier which has 28 bits. Collecting information. Creation of forwarding tables in both unicast and multicast routing involves two steps. 1. A router needs to know to which destination it is connected. 2. Each router needs to propagate information that is obtained in the first step to all other router so that each router knows to which destination each other router is connected. Unicast versus multicast advertisement. This diagram that shows the representation of the unicast versus multicast advertisement. The diagram in the left hand side which shows the unicast advertisement, the diagram in the right hand side which shows the multicast advertisement. Multicast forwarding. Another important issues in the multicasting is the decision a router needs to make to forward multicast packet. Forwarding in unicast and multicast communication is different. Destination in unicasting and multicasting. Figure A that represents the destination in unicasting is 1 and the figure B that represents the destination in multicasting is more than 1. Forwarding depends on the destination and the source. Figure A packet sent out of two interfaces. Figure B, a packet that sent out of one interfaces. Two approaches to multicasting. In multicast routing, as in unicast routing, we need to create routing trees to optimally route the packets from their source to their destination. So, the multicast routing decision at each router that depends not only the decision of the packet but also on the source of the packet. The involvement of the source in the routing process that makes multicast routing that much more difficult than unicast routing. So for this reason, two different approaches in multicast routing that have been developed. Routing using source based trees and routing using group shared trees. Shortest path tree in unicast routing. So this figure that represents the shortest path tree in the unicast routing. This is the diagram that represents the group shared tree approaches. Here we are using the core router and different number of routers for the transmission of packets. So during the last few decades, several intra-domain multicast routing protocols that have been emerged. So out of these protocols, the extension of unicast routing protocols are RIP and OSPF. Using the source-based tree approach, the third is an independent protocol which is become more and more popular. The distance vector routing protocol, that is DV MRP, is the extension of the routing information protocol which is used in unicast routing. It uses source-based tree approach to multicasting. It is worth mentioning that each router in this protocol that have receives a multicast packet to be forwarded implicitly also creates a source-based multicast tree in 3 steps. Using RPF, end receives 2 copies. Using RPF, end receives only 1 copy. In this diagram, using RBP, all networks receives a copy. Using RBM, only members receives a copy. So multicast open shortest path first MOSPF is the extension of the open shortest path first protocol which is used in multicast routing. It also uses the source based tree approach to multicasting. If the internet is running a multicast link state routing algorithm, the idea that can be extended to provide a multicast link state routing algorithm. To extend unicast to multicasting, each router needs to have another databases. As with the case of unicast distance vector routing, to show which interface has an active member in a particular group. So this is the example of a tree formation in MOSPF, an internet with some active groups, and figure B, S to G1 shortest path tree, figure C, S to G1 shortest seen by current router, and figure D, S to G1 pronounced subtree. PIM, Protocol Independent Multicast, PIM is the name given to a common protocol that needs a unicast routing protocol for its operation. But the unicast protocol that can be either a distance vector protocol or a link state protocol. In other words, PIM needs to use the forwarding table of a unicast routing protocol to find the next router in the path to the destination. But it does not matter how the forwarding table is created. PIM has another interesting feature. It can work in 2 different modes. First one is dense and another one is sparse. So this is the idea behind PAM and DM. Diagram A, first packet is broadcasted. Diagram B, how the second packet is multicasted is given in this figure. Idea behind PAM and SM is three networks to join group 1, that is shown in figure BA, and figure B, multi-tree after joins, and figure C, one network that leaves group G1, and D, multicast tree after pruning.